Okay. Today we are discussing about generations of operating systems. See, there are four generations of computers, and each generation of computer we are discussing what operating systems we have used. So first generation is from 1945 to 1955. Second generation is from 1955 to 1965. Third generation is from 1965 to 1980. Fourth generation is present current generation where we are using personal computers. Okay. So let's come to first generation. In this particular generation, the computers are made up of vacuum cubes and plug boards are cubes and plug boards. The machines are enormous, mostly filling up the entire rooms and tens and thousands of vacuum tubes. And these are very much slower to the current machines that we are using, the PCs that we are using. And the programming language, there is entire programming, we have to do it in machine language. What is machine language? The programming will do it in zeros and ones. That is your machine language. So the processing is serial processing. Currently we are using parallel processing, but the processing serial processing, that means at any point of time only one program is executed. If that particular, until and unless the particular program is executed, then we will move to next program. If the program is not executed, then all the programs has to wait for the first program to be executed. Okay. So why these are used? Because of calculating calculations such as sines and cosines and logarithms, these are used. Okay. So here, almost the first computers that are designed in this particular generation is ENIAC. IENIAC. What is ENIAC? The full form is electronic numerical integrated and computer. Integrated and computer. So this is called ENIAC. Let's see the diagram of the picture of ENIAC. So this is the ENIAC computer, the backside, where you can see the vacuum tubes, and you can see the vacuum tubes and plug boards and how the connections are made up. Okay, the name here, ENIAC. The world's first computer is world's first programming computer. So this one is first generation computer is ENIAC. Okay, electronic large scale general purpose digital computer, general purpose digital computer. Okay. So entire coding is done in binary language only, so there is no high level language here. We need to use high level language means a b c d's and 1 2 3 4 whatever we are using daily. But the programming language, there is no absolutely no operating system that is used in this particular computers. And the language that we have used to write the program and codes are zeros and ones, machine language or binary codes. So this is the setup. It occupies entire room in the particular the computer occupies entire room to calculate sines and cosines, logarithms, and all trigonometric values and etc. And the next, we are going to second generation computers, and here we are using an operating system. The first time the operating system that is used is in the second generation. The batch operating system is used here. So what we are using in this particular second generation. Second generation, the transistors are used instead of vacuum tubes. The vacuum tubes are replaced by transistors, and the size is also reduced when compared to first generation computers. And these machines are called mainframes. They are very costly, and only big and multinational and multi-level corporate companies can able to afford, that is buy these particular computers. Okay. So next, the operating system that is used here is batch operating system. We will discuss about batch operating system later. So there are some particular what is mean by batch operating system or batch systems. There are some particular programs P1, P2, P3, P4 and P10 etc. There will be some similar type of programs are there. We'll group this similar type of program. Suppose that the language that we used in this particular second generation is Fortran. So Fortran, suppose that there are three programs that are related to Fortran. Out of 10 there are three programs that are related to Fortran. So the compiler, the operating system has to load Fortran compiler. So once you load the Fortran compiler, all the programs that are related to Fortran will be batched or grouped together, and the system will execute this particular group of programs that runs with Fortran compiler. So if there is any other one more any other language will be there, that particular language compiler will be loaded, and the programs will be executed corresponding to their compiler or their language compiler. Okay. So second, the large second generation computers were used mostly for scientific and engineering calculations. Here with the scope is extended to scientific and engineering calculations. So now there only sines, cosines and trigonometric values, angles will be calculated. Here we are using partial differential equations and integrated equations that is occurred in your physics and engineering engineering departments. So they were largely programmed in Fortran only, Fortran and assembly language. Okay. The operating systems here we are using is Fortran Monitor System, FMS, and there is IPSYS. IBM, they are designed by IBM, IPSYS. Okay. So next we will see what this. So this is our second generation computer. Second generation computers. Okay, so the size will be reduced to some extent compared to your first generation vacuum tubes computer. Third generation computers where that are transistors will be replaced by integrated circuits. Large integrated circuits are used here. The IBM introduced System 360. The systems are called Systems 360, which is run by operating system OS 360. Okay, System 360 is a software compatible machine, and the performance of this particular systems is improved using integrated circuits and integrated chips. Here, instead of batch operating system or batch processing, and the second generation mostly they are used on FCFS approach. That is, whatever the program that comes first, that will be executed first. If that particular program, suppose P1 has went for some IO, that means it needs to take print of 10 pairs or 100 pairs. Until and unless P1 will take all 100 pairs of printout and comes out, the P2, P3, P4, the remaining programs or tasks has to wait until this particular P1 will go and take 100 pairs of printout and then completes its execution, then only P2 is allowed. That is called FCFS. So all the second generation computers uses FCFS only. But in third generation, there is a concept of multi-programming model was introduced. What is multi-programming model? When P1 went for IO, the CPU will stay idle. The CPU will stay idle. So at the time P1 went for IO to take printouts, the processor will be idle. The processor does nothing until and unless P1 will take 100 pages of printout and comes again to process CPU. It will not do anything. The CPU will be idle. So what we will do? Whenever a process is went for IO, that is taking printouts, then the next process which is in the queue will be loaded to CPU. So CPU will execute P2. If P2 also went for IO, then the next process that is in the list, that is P3. P3 will be entered into CPU and starts executing its instructions. That means if any process it needs an IO, then it goes for IO device. Then the CPU will be idle. So we will send the next process in the list to CPU. If that process is also went for IO, then we will send one more process, the next process in the list to CPU, so that CPU will be busy all the times. And these processes are stored in job spooling. The list of process which are lining in a queue is called job spool. Okay, so which P1, P2, P3 and so on P10 we will be residing in that particular spool. And when it comes to second generation and third generation, here we will these third generation computers are used highly for scientific calculations and mostly the commercial data processing. Okay, so what are the different computers and computer models that you have used? There is first third generation computer is Multics. They call Multics computer, and they have introduced client server model. They have introduced some software called middlewares, and the operating systems they are used called distributed operating systems, mini computers. And during this particular period, 1965 to 1970, the currently and most popular operating system, that is Unix operating system, is introduced. Along with this one, there is a popular programming language called C language is also introduced this particular time period. Okay, so most of the Unix operating system is actually written in C language. Okay, the next, so this will be your third generation computer. The size is reduced very much as compared to your second generation computer. And let's see fourth generation computer, that is today's computer, that is 1980s to present. Nowadays we are using multitasking. Third generation, they have introduced the concept of multitasking or multiprocessing, but here in fourth generation they have used multitasking completely. And they are, the current generation is fourth generation, what we are using large scale integrated circuits we are using. So personal computers has been introduced in this particular generation. 8-bit or 16-bit microprocessors we are using, and currently we are using 630 to 64-bit architect microprocessors. Okay, so whatever the computers that you are looking at nowadays, personal computers, desktops, laptops, mobiles, and tablets, and everything that comes under fourth generation. Okay, so the operating systems that we are looking at, the first fourth generation operating systems are Apple DOS, Microsoft Disk Operating System, CPM, control program for microcomputers. They have all are command line interfaces. Then after some particular period of time, they introduced graphical user interface based on the operating system. So Mac OS, Windows OS versions, that is Windows XP, Windows 7, Windows Vista, Windows 10, Windows 11. Currently, Windows 11 we are using, and Unix OS like Linux and Ubuntu Linux, Ubuntu, Solaris, all are graphical user interface, GUI based interfaces. Okay. Then the most widely system architecture that is in fourth generation is networks and distributed computing. Network and distributed computing. So that means the data will be distributed in several areas, and data will be accessed from anywhere in the world. So they introduced two operating systems called network operating system and distributed operating system. These are used in client server paradigm. Client server paradigm, we will use network operating system and distributed operating system. Okay, so that's it. We'll discuss some of the terms in the coming classes. So until now, this is our generations of computers and the corresponding operating systems that we have used. In first generation, we did not use any operating system. Second generation, we have used batch systems. Third generation, we use Fortran based. Fourth, multiprocessing and multi-programming operating system, the operating that supports multi-processing and multi-programming. Fourth generation, the current generation, we are using distributed networking operating systems. Okay, thank you.